y minus y1 equals the slope times x minus x1. All nice, but what I am missing is this. Till I find this, I cannot find the equation. So, any suggestions on how to proceed?
Find dy dx.
Very good. But no one can solve this equation for y. So we have to find dy over dx, which means that this is not a variable. This is not a variable. And this is not a variable. It's a function of x. I will apply the same operator to both sides. The operator is differentiating. Now I have to be super careful because this is a product. Function 1, function 2. I differentiate function 1 and I get 2x. I have to multiply by function 2. Plus, I copy function 1 and I multiply by function 2 prime. Chain rule with the power rule. 2 y to 2 minus 1 times the inner function prime. This is finished. Equals function 1, function 2. I differentiate function 1. 2 y plus 1 times the inner function prime, dy over dx, but this is prime is 0. So times dy over dx times function 2 plus function 1 times function 2 prime. I'm not going to have enough room, so I'm going to go here already. Oh, no, this doesn't have a power. That's fine. So times negative 2y. There is no power here. I mean, it's power 1, so I don't have to do anything. So this prime is 0. This prime is 2, negative 2y times dy over dx. I was able to squeeze it in there. A mess. Total mess. So now let's see what we're looking for. It needs to be cleaned up, but this is a term that has dy over dx. This is another term that has dy over dx. They will stay on this side. But this is another term that has dy over dx. So this stays on this side. This moves to the other, and all these three will be factored, right? This is the common factor, dy over dx. Okay. So 2xy squared equals, this is positive 2x squared y, but goes to the other side as negative 2x squared y. This positive 2y plus 1, 4 minus y squared. And then minus 2y and y plus 1 squared. So I'm going to change this into a bracket, not to be confused, not to confuse you with anything here. Okay, so let's stop for a moment. This does not have the variable, is alone on one side. This one has the variable. So it's 2x squared y, but it has positive, and I move it to the other side, becomes negative. And this is outside because I factor it in one step. Then this is positive, 2y plus 1, 4 minus y squared. This is out here. And this is negative 2y and y plus 1 squared. Now I'm going to try and simplify a little bit in brackets, see if we can, And that's the final dy over dx. So dy over dx, this is at the top. Now let's see what I can do here. It's awful. So, but I chose it, so I can't complain. So I'm just going to keep it as is because they're asking us to find a value. So, and minus 2y, y plus 1 squared. So all I need to do now, when x is and when y is. I don't need to do anything with it. X is 2 to the square root of 3, and y is 1. And that's it. So now let's plug it in. 2 times 2 to the square root of 3 times 1 squared. Fine. Negative 2, and this is 4 times 3 is 12, and times 1. Let me put it so everyone understands. So negative 2, this squared, this is 4, but this is 3. 4 times 3 is 12, and times 1, and then plus 2. Y plus 1 is 2. 4, oh, that's 4 minus 1 squared, so that's 3. I was going to say it's 0, but it's not. Minus. So 2 times 1 is negative 2. 1 plus 1 is 2. 2 squared is 4. Not too bad. Okay, let's see. So this is for the square root of 3 in the numerator. This is negative 24. This is positive 12. And this is minus 8. And finally, for the square root of 3 over negative 24 plus 12 is negative 12. Negative 12 minus 8 is negative 20. I'll simplify. And I get negative the square root of 3 over 5. And now I have the final y minus 1 equals the slope that we just got, negative the square root of 3 over 5 times x minus 2 the square root of 3. I will distribute. It's okay, so then I have here positive. So this is 2 times 3, which is 6 over 5, and plus 1. Not too bad at the end. So 11 over 5. So this is 11 over 5. I'll write it again. And this is the equation of the tangent line to the graph of whatever that is at the given at the given point. So this is y equals negative the square root of 3 over 5 plus 11/5. And that's implicit differentiation. A lot of work. For this particular one, definitely. Any questions on implicit differentiation? Let me know if it makes any sense. Anyone?
Makes sense. Just a lot of steps.
A lot of steps. Oh, absolutely. And you have to be very careful. So first of all, I had to apply the product rule twice. I had to apply the power rule and the chain rule on functions. So y squared prime is 2 times y times dy over dx. 2 times y times dy over dx. A lot of steps. And then after we differentiate, basically this is algebra now. There's nothing to do with calculus. I just have to realize that I have 3 terms, 1, 2, 3. These 3 terms have the variable. and this one doesn't, and separate the variable from the rest. So separate the term that does not have the variable from the 3 terms that have the variable and factor out the variable, which is just this, dy over dx. And then realize that this dy over dx is this over the whole thing. There was no point in me trying to simplify it because the problem was not asking us to determine a nice form for dy over dx, was asking us to find the slope when x is 2 to the square root of 3 and y equals 1, so I could just simply plug it in. Once we get the answer, which is only arithmetic, it's algebra, I got the answer. Again, I used algebra to find the equation. So basically, there is only one step that has calculus in it. Only this step. All the others are simply algebra. Would you like to upload anything so I can make sure that you paid attention to anything that we looked at?